channel Dawn of Chemistry. Hope you are all happy and healthy in your homes. Stay home, stay safe. In this video, we are going to discuss about the solubility product, finding the solubility of a particular salt, finding the solubility of salt in presence of a common ion. This is a very important topic, and definitely you can expect one question based on this solubility product, solubility and solubility product calculation in presence of a common ion. In the recent NEET 2020 examination also, one question has come to identify, to find the solubility of a salt in presence of a common ion. So let us see what is this solubility product and what are the things regarding this. See, if you are new to this video means try to subscribe to the channel and click the bell icon for the notifications, and don't forget to like the video and share the video. See, solubility product. What is this solubility product? To understand this solubility product, first you should know how many types of salts are there. Basically, salts are classified into soluble salts, partially soluble, and then sparingly soluble. So basically, salts can be classified into three types. One is soluble salts and partially soluble salts and sparingly soluble salts. How they have divided these things means, when a particular salt dissolved in water, if its solubility is greater than 0.1 molar, if the solubility of the salt is greater than 0.1 molar, that is known as a soluble salt. If the solubility is between 0.1 molar to 0.01 molar, then it is known as a partially soluble salt. And finally, sparingly soluble salt means if a salt is having solubility less than 0.01 molar, then it is known as a sparingly soluble salts. What is this solubility? Solubility means the maximum amount or moles of salt that can be dissolved in 1 liter of solution is called solubility. To understand the solubility product, first we should know the solubility method. That's why I am explaining this. So the maximum amount of salt that can be dissolved in 1 liter of solution is called the solubility. What are the units of this solubility means grams per liter or moles per liter will come. If moles per liter is given, grams per liter is equals to gram molecular weight into moles per liter you have to do. So this is a very important relation. So whenever a particular salt dissolved in water, that undergo dissolution in the given solvent. So that's why the maximum amount of solute that can be dissolved in that is known as the solubility. Based on this solubility, three types of solutions are present. What are the three types means? Soluble salts are there. Soluble salts means which are having the concentration greater than 0.1 molar means they are the soluble salts. If they are partly soluble means if the concentration is between 0.1 molar to 0.01 molar, they are known as the partially soluble salts. And finally, sparingly soluble salts. If the concentration is less than 0.01 molar means they are known as the sparingly soluble salts. In this case, we will study about the sparingly soluble salt. So what is this solubility product and what is a sparingly soluble salt means? When a sparingly soluble salt dissolved in water, what happens means, see, examples for the sparingly soluble salts are silver chloride, silver bromide, silver nitrate, magnesium chloride, zinc chloride, zinc sulfide, and barium sulfate. Like that, there are number of salts we are having. When these salts dissolved in water, what happens means, see, I will take example of barium sulfate. When you take barium sulfate and dissolve in water, it will dissociate into barium ions, and then sulfate ions will be coming. The formed barium ions and then sulfate ions will combine back to produce the barium sulfate. That's why there will be equilibrium between the dissolving reaction as well as combining reaction. Since there is equilibrium between the dissolving and then combining reaction, it will have an equilibrium constant. Right. So since it forms a reversible reaction, these salts are sparingly soluble. When a sparingly soluble salt dissolved in water, see, when it is dissolved up to the maximum capacity means that is known as the saturated solution. So if any solution is prepared more than its solubility, then it is known as a super saturated solution. Super saturated means precipitate forms. And if any solution is having the lower quantity than its solubility, then it is known as the unsaturated solution. So basically there are three types of solutions are present. Any solution which is formed up to its solubility means then it is known as the saturated solution. If the salt is more than its solubility capacity means then it is known as the super saturated solution or precipitate formation takes place. If the solubility or the solution is having lower quantity than its capacity means then it is known as the unsaturated solution. So now you see, whenever any salt you take and dissolve in water, because of equilibrium formation, it will be sparingly soluble. Since it is sparingly soluble, at saturation point, see, I am underlining this thing, at saturation point, the product of concentration of ions, if you take AlCl3, you will understand this clear. Al3 plus and 3Cl minus. The product of concentration of ions raised to the powers equal to their stoichiometric number. The product of concentration of ions raised to the powers equal to their stoichiometric number in a balanced chemical equation, in a balanced dissolving equation is called the solubility product. So KSP equals to Ba2 plus into SO4 2 minus. For this one, KSP equals to Al3 plus into Cl minus power 3. Why means 3 are present, so that's why we will write like this. So see here, solubility product, the name itself indicates it's a product means multiplication. The product of concentration of ions raised to the powers equals to their stoichiometric number in a balanced dissolving equation at saturation point. At saturation point is known as the solubility product. This is the perfect definition for the solubility product. So the product of concentration of ions raised to the powers equals to their stoichiometric number in a balanced equation at the saturation point is called the solubility product. So this is the example salts. Let us take a common salt and derive the expression. Hope you understood this thing. So let us take a salt AXBY. This is a salt. So when you take this a salt and dissolve, You know very well, NaCl gives Na plus plus Cl minus, MgCl2 gives Mg2 plus plus 2Cl minus, Al2SO4 thrice gives 2Al3 plus plus 3SO4 2 minus. So these are the numbers of the opposite ions. So in the same way, AxBy gives XaY plus plus YB X minus. This is the thing. Let us take solubility of NaCl is 1 molar. Chloride concentration, sodium is 1 molar. Chloride is 1 molar. MgCl2 solubility, let us take 2 molar. Magnesium concentration will be 2 molar. Chloride concentration will be 4 molar. If this solubility is 3 molar, this concentration will be 6 molar and this concentration will be 9 molar. If the solubility of this salt is S, solubility of AY plus will be XS, solubility of B minus will be YS will be coming. Understand this very carefully. If the solubility of the salts is this one, means the concentration of ions will be XS and then YS. Now let us see solubility product. KSP is equals to AY plus concentration whole power X, BX minus concentration whole power Y. Here you can understand this very clearly. The product of concentration of ions raised to the powers equal to their stoichiometric number in a balanced solubility reaction is known as the solubility product. We know very well what is the concentration of AY plus means XS power X, BX minus concentration is YS power Y. So it will become X power X, S power X, Y power Y, S power Y. And finally what you can conclude, this thing means X power X, Y power Y, S power X plus Y is equals to KSP. From this thing, S is equals to KSP by X power X, Y power Y whole power 1 by X plus Y will come. This is the relation between solubility product and then solubility of a reaction. Be careful, they will give you one particular salt and they will ask you find the solubility of the salt. So to find the solubility of the particular salt, you should be very careful whether you are finding the solubility in moles per liter or grams per liter. This is a very important thing and you have to remember this. Whether the option they have given you in moles per liter or whether they have given you in grams per liter, you have to be very careful about that. They will give you any of the salt. Let us see for some common type of salts what will be the solubility relation. Let us take different types of salts and let us see the things. Take AB type of salt, AB2 type of salt, AB3 type of salt, A2B3 type of salts. These are the major types we can be having. Or you can take AB4 type of salt also. For these things, let us write the solubility relation as well as units of KSP. This is also very important thing. Sometimes by looking at the units of KSP, you can assess what is the type of salt. S is equals to, in this case, X equals to 1, Y equals to 1. So that's why S is equals to KSP by 1 power 1, 1 power 1, 1 by 1 plus 1. So S is equals to root over KSP. In this case, X equals to 1, Y equals to 2. S is equals to KSP by 4 whole power 1 by 3. Because X power X, Y power Y. 2 power 2 means 4 will come. Whole power 1 by X plus Y. AB3 type of salt means KSP by X equals to 1, Y equals to 3. So that's why 3 power 3 means 27, 1 by 4, because X plus Y will be 1 plus 3, 4. S is equals to KSP by X equals to 2 and Y equals to 3. 2 square means 4 will come, 3 cube means 27. 27 into 4. What will be the 27 into 4 means 108 whole power 1 by 5. And finally this one, S is equals to KSP by 4 power 4. 256 whole power 1 by 5 will come. Like this, we can identify the relation between solubility and then solubility product for the different types of salts. Now, units of KSP. You know very well, product of concentrations raised to the power equal to their stoichiometric number. This is 1 and this is 1. So, the unit will be moles square liter power minus 2. This case, mole cube liter power minus 3. See, I will tell you. KSP is equals to concentration of A plus into concentration of B minus. Mole liter inverse power 1. A power m into A power n equals to A power m plus n. So, mole liter inverse power 1 plus 1. So, moles square liter power minus 2 will come. That's why it will come. In this case, it will be mole power 4 liter power minus 4. Mole power 5 liter power minus 5. Mole power 5 liter power minus 5 will come. Like this, we can study about the what is solubility product, what is the definition of solubility product, how can you define solubility, what are the units for the solubility, what will be the relation between solubility and then solubility product for the normal salts, and what will be the units for the solubility product for different kind of salts. And solubility can be asked in the moles per liter and then grams per liter. So be careful with those things. Now let us see what is the application of this solubility product. There is another product known as the ionic product of a salt. The product of concentration of ions raised to the powers equal to their stoichiometric number at saturation point is solubility product. At other points is nothing but the ionic product. These are similar to the reaction quotient and then equilibrium constant. Hope you have taken down these things. So I am rubbing this. So let us see ionic product. KIP is equals to, for AX, BY only, AY plus whole power X, BX minus whole power Y at any point. At any point, that is nothing but the ionic product. Now let us see the relation. If KIP equals to KSP, the solution is saturated solution. KIP greater than KSP means precipitate formation takes place. KIP is less than KSP means that is unsaturated solution. So like this, whenever you take anything, the solution, you have to see the ions concentration in a particular solution and you have to see the product of them. So between the product of them, you can identify by relating with the solubility product, and you can identify whether precipitate formation takes place or not. This is very, very important application in case of inorganic analysis. That is very, very important thing. Total inorganic analysis is based on this solubility product and then common ion effect phenomena. Common ion effect I will explain, let us see. So that is the thing regarding what is the solubility product and what are the things done. Let me explain one problem based on the solubility product. In a solution, 0.01 molar magnesium ions are present. If KSP of MgOH twice is equals to 1 into 10 power 4 into 10 power minus 9. At what pH the precipitate formation takes place? So see, in a solution 0.01 molar magnesium ions are present if Ksp of MgOH twice is 4 into 10 power minus 9. At what pH the precipitate formation takes place? This is very important thing. So let us see. You know very well, Ksp is equals to magnesium concentration into hydroxide concentration whole square. Ksp value is 4 into 10 power minus 9. Magnesium concentration is 10 power minus 2. Hydroxide concentration whole square. Welcome. That's why better you take this as 10 power minus 8. Then calculation becomes simple for us. 10 power minus 8. This comes this side means 10 power minus 2 comes down, goes to top means plus 2. So 4 into 10 power minus 6 equals to OH minus whole square. So that's why OH concentration is equals to 4 into 10 power minus 3. So POH is equals to minus log of OH minus, so minus log of 4 into 10 power minus 3, 3 minus log 4. Log 4 is 0.6, so 2.4. So POH is equals to 2.4. POH equals to 2.4 means pH is equals to 11.6 will come. So when pH is greater than 11.6, precipitate formation takes place. So listen to this carefully. Whenever they give you like this concentration of magnesium ions and the solubility product, first you should know what is the OH ion concentration. At that concentration it is saturated. If once it crosses that particular concentration means automatically precipitate formation takes place because KIP will be greater than KSP. So that's why more than this pH precipitate formation takes place. So that is the thing regarding the what is the solubility product and all. One more important question, let me explain. Which of the following will have maximum solubility? Option A, AB salt with Ksp value 4 into 10 power minus 10. AB2 salt 32 into 10 power minus 15. AB3 salt 16 into 27 into 10 power minus 20. Option 4, AB4 salt. Next, B, C, D. All are same. So see the question. There is no proper factor which explains the solubility. Because solubility they can ask you in terms of moles per liter or grams per liter. So which will be having more solubility in grams per liter or which will be having more solubility in the moles per liter. If they ask moles per liter means no need to worry about, directly you can do. But if they ask in grams per liter means you should be very careful about the gram molecular weight of a substance. So let us see what is the solubility means. Root over Ksp. So 2 into 10 power minus 5 moles per liter. For this thing, root over Ksp, what is the S is equals to Ksp by 4 whole power 1 by 3. So that's why this also will become 2 into 10 power minus 5. For this thing, S is equals to Ksp by 27 into 1 by 4 will be coming. For this thing also 2 into 10 power minus 5. So all will be same. If they ask you in grams means that time the change will happen. If they say NaCl, MgCl2, AlCl3, which will be having more solubility means gram molecular weight, whatever is having maximum, which is having more gram molecular weight means AlCl3. So AlCl3 greater than MgCl2 greater than NaCl will come. If the solubility is in terms of moles per liter means all will have the same solubility. If the solubility is in gram molecular grams per liter means AlCl3 greater than MgCl2 greater than NaCl will come. Like this we can study about the what is the solubility product and how we can identify the solubility based on the solubility product.